Hi guys, so today we're going to be looking at Chapter 4, Section 5, Rules of Exponents. So today's goal is to simplify expressions using the rules of exponents. We'll first start off by understanding how to use the products of powers property to identify the product of an expression. Then we'll learn how to understand how to use the quotient of powers property to identify the quotient of an expression. Afterwards, we'll use both of those rules to try and simplify an expression, or you'll see as a fraction. So let's start off with the product of powers property. Now, before we get into this problem, I want you to try out this review question first. So the question is asking you to expand the following expression. And I'll give you time to do this on your own. All right, so we have here a to the power 2 times b to the power 2. If I were to expand this, I would write down we have here a times a, and then we're also multiplying here b times b. Down below, for m to the power 4 times m to the power 2, I'm multiplying m 4 times, and then I'm multiplying m twice. Okay? So this is important to understand because for the products of powers property, let's say that we're looking at the second problem that we completed, which was m to the power of 4 times m to the power of 2. When we expanded that expression, right, we got m multiplying 4 times and then m multiplying twice. Now, if I were to count how many m's there were in this expression, I could find m to the power of 6. So this kind of gives us a rule that we could use, which is this formula where if you have the same base, so you have to make sure that your bases are completely the same, you can add the exponents together if you are multiplying both terms. And so right here, we're doing the same thing where we have m to the power 4 and it's multiplying with m to the power 2. And so because we're multiplying those two m's together, we can add up the exponents where we get m to the power of 4 plus 2. Now we can only do that when we're looking at a base that is exactly the same. So if we were to go back to the question here, it wouldn't be possible for us to use the product powers property on a to the power 2 times b to the power 2 because of the fact that they do not have the same base. But we can with this expression because of the fact that they're multiplying by the same base. We're multiplying by both m's. And so in this case, we could add the exponents together and we get m to the power of 6 as our answer. Okay. Let's continue on. All right, quotients of powers property. Again, I'm going to move to the next question first. Again, this is a review question. You're going to solve the following problem. It says here that you have 12 divided by 12. We want to know what that equals to. And then afterwards, you're going to find out what p divided by p equals to. I'll give you a few minutes to do this on your own first. All right, so 12 divided by 12, that gives us 1. P divided by p, we know that any number divided by itself gives you the answer 1, just like it's shown here with 12 divided by 12. So if p, for example, was equal to 100, 100 divided by 100, that still would equal to 1. 1,000,002 divided by 1,000,002 would also equal to 1. And so we could say here that since they are the same variable, where we have the same letter dividing by itself, we could say that this is equal to 1. And this is really important to understand for the quotient powers property. So what happens when you divide two powers of the same base? I want to first start off by expanding the expression here. We have a times a times a times a times a dividing by a times a. Now what I could do here is I could take this a and the a on the bottom and divide it with each other. If we divide a divided by a, we get the answer 1. So already we get 1 times a times a times a times a divided by a. Now 1 times anything will equal to whatever that number is that the 1 is multiplying by. So we still get a times a times a times a over a. Let's try it again. We also have here an a, and we can divide it with this a. So if we do that, we get 1 times a times a times a. And that would just equal to a times a times a. And that would be a to the power of 3. Now, this is a longer method, and so a nice rule to note here is that if you have an exponent that is bigger on top, so we know that the 5 is bigger, then what I'm going to do here is I'm going to subtract the 5 with the 2, and then I'm going to write down a 1 because this area is going to be left empty since I'm moving that 2 to the top. And so I get here a to the power of 3 over 1, which just equals to a to the power of 3, right? Now, the second method is, let's say that we have here a to the power of 3 dividing with a to the power of 7, okay? In this case, we see that the 7 is the bigger exponent. So that means that I want to get my a to the power 7 and subtract it with the 3. But the important part is to note that this is happening on the bottom of the fraction. And so instead, I'm just going to leave a 1 on the top of the fraction. So right here, we get 1 over a to the power of 7 minus 3. That equals to a to the power of 4. And so as you can see, it's really important to note where the bigger exponent is, okay? If the bigger exponent is on the top, that means that you're subtracting on the top of the fraction. If your exponent is bigger on the bottom, that means that you have to subtract on the bottom of the fraction. Okay? And that's what we call the quotient of powers property. So let me clear that. And then let's move on. So far, we learned about the product of powers property. We also learned about the quotient of powers property. Now we need to use both of those rules and try and simplify an expression. So for homework, you're going to see that you're going to be given a fraction and you're going to be asked to simplify. Right here you have 3m to the power of 5 times m to the power of 2, and it's dividing by 6m to the power of 3. So the thing that I like to do is I like to take out the numbers from the fraction. So I have here 3 over 6, Over here I have m to the power 5 times m to the power 2 divided by m to the power of 3. Now based off of this, I like to look at my numbers first. So we have here 3 over 6. I know that I could divide that by 3 to both my numerator and also my denominator. When I do that, I get 1 over 2. So I could change this fraction into 1 over 2. Cool. Let's look at the top of the fraction first. The top of the fraction has m to the power 5 times m to the power 2. Based off of the product of powers property, I know that since they have the same base, I can combine them together and add the exponents. So here I get m to the power of 7. Okay. Underneath I still have my m to the power of 3. Okay. Let's look at how we can simplify the m to the power 7 and the m to the power of 3. So it's telling me here that the exponent is higher or bigger on the top of the fraction, which means if I'm going to subtract, it's going to have to be on the top of my fraction. And we said that the empty area is always going to be left with a 1. So here we get m to the power of 4 over 1, and that just equals to m to the power of 4. So I could change this. So I have here 1 over 2, and then actually I'm going to leave it as m to the power 4 over 1. That might make my fractions a little bit easier for the moment. We have here m to the power of 4 over 1. And now I want to combine both fractions together. So I have 1 times m to the power of 4. I also have here 2 times 1. We get m to the power of 4 over 2. And there's nothing that I could do to simplify it anymore. So that would be my answer. Okay. Let me clear the slide and let's try it out. So the question here is asking you to simplify the following expression. You're going to simplify a to the power of 4 times a to the power of 2, and you're going to divide it by 2a to the power of 3. I'll give you time to try and simplify the fraction that is given. Alright, so let's try it out. We have here a to the power of 4, a to the power of 2, 2a to the power of 3. There isn't a number on top, so that means that there's nothing I can simplify with that 2. So I'm just going to leave it alone. Now, I can combine the a to the power 4 and the a to the power 2. Again, we said that if we have the same base and they're multiplying with each other, we can add the exponents together. So I get here a to the power of 6. Okay? So if we have here a to the power 6 to a to the power 3, I can also see that I can simplify this as a fraction. I have here a to the power 6 over a to the power 3. It's telling me that the exponent is higher on the top of the fraction. So that means that I'm going to be subtracting on the top, and I'm going to leave a 1 on the bottom of the fraction. So here I would get a to the power of 3 over 1. So now I have 2, and since we have an a to the power 3 that goes on top, the 1 is going to go on the bottom. So I get here a to the power 3, 2 times 1, that just equals to 2. So that would be my answer. So hopefully this helps. Good luck.